Hello everybody, welcome to FSI 306. I am Kirti, I am a Senior Solution Architect here at AWS, and I'm glad to have Rick Fath with us today. He is a Senior Director for Platform Engineering at CME Group. We are going to talk about how CME Group enable data science through event-based design. Every now and then we hear about company mergers and acquisitions, and I'm sure many of you who are sitting with us today have either worked for a company which acquired some company or which got acquired by some company. The success of acquisition often depends on how soon we are able to integrate the two companies together. While integration, major chunk of effort is put into data integration, especially today when data scientists have never-ending appetite for alternative data. We are going to share with you how CME was able to leverage AWS services so that they can do this data integration early on, so that they can run analytics or create models by combining their data with the newly acquired data, so that they can get business insights as well as increase revenue. But this was not all. They were able to use the same architecture to solve for other business use cases, which we will discuss as part of the presentation. This architecture we have divided into 5 different parts, which Rick will be walking you through. It's into data collection, data routing, data transformation, data access, and data science. This architecture unlocked many of data science use cases for CME, like understanding market performance around global events, fraud investigation, designing new pricing calculations, and many more. We will wrap up the sessions with lessons learned and next steps. Now, without further ado, I would like to hand it over to Rick.
Thank you, Kirti, for that warm introduction. It's a pleasure presenting with you today. Hello, everyone. My name is Rick Fath. I'm Senior Director of Platform Engineering at CME Group. My primary responsibilities at CME Group are focused around cloud adoption, as I have a primary responsibility for cloud architecture. In addition to my architectural responsibilities at CME Group, I have the privilege of leading up a development team in our platform engineering organization that focuses on building innovative data services to meet our data needs within CME Group around critical business capabilities, including things like data science and data management and our data lake. It's a really exciting time at CME Group right now. Recently, we've acquired several companies as part of a business initiative. And with that, a lot of new challenges have been presented to us in terms of how do we integrate with these third-party, new organizations. In addition to that, we've also have a growing data-driven culture within our business organization that requires us to pull in data sets that previously were out of reach. And I'm talking specifically around SaaS data platforms like Salesforce, Facebook, Twitter, Google Analytics. There's a lot of appetite to harness these data sets and bring them in to find valuable insights for our users. Having been in this space for a long time, I can say that one of the things that most organizations struggle with is capitalizing on their data investments. It's a very difficult practice around data engineering, data procurement, data access, as well as having the capabilities in your data science departments to ask the right questions and get to the business insights. I'm happy to talk today around an innovative solution that we were able to realize to address some of these challenges. In this talk today, we're going to walk through the architecture, our data ingestion architecture, as well as around what our data science community was able to achieve with the combined efforts of our teams. So with that, let's begin. Before we talk about the specifics around our data procurement or our data ingestion architecture, I thought it would be important to talk and describe who we are at CME Group. If you're not familiar with CME Group, it also is important to potentially talk about where we've come from as a means to set the stage for that. How many people can say they work for a company that's 122 years old? Originally, the Egg and Butter Board, CME Group in the late 1800s, was a marketplace for egg and butter providers and consumers to get together to negotiate around a future price and delivery for those products. This is essentially one of the first kind of installments of a futures contract. Shortly after that, the name was rebranded to the CME Group, the Chicago Mercantile Exchange. Beyond that, the next evolution at CME Group was really the creation of the pits. These octagonal trading floors, which are iconic symbols of our industry, where we have the traders and the colored jackets representing their firms and communicating over hand signals, right? And the chaos that ensues at the closing bells. This is essentially one of the cornerstones of our markets in terms of represents what free, the marketplace brings. Taking that further, the next and probably most influential advancement in our industry was the age of electronic trading. This allowed us to reach more customers and more countries across the globe. This is the age of algorithmic trading, high-frequency trading, and where latency is key to meeting the positions that you need to meet your business's needs. Now, in all of these examples, from the very first installment in the early 1900s all the way to today, our business, of all the changes that have transpired, our business mission has never changed, which is very interesting. We are the place where the world manages risk, right? CME Group provides a marketplace for producers or hedgers to come to offload their risk of their products to speculators in seek of profit. And that has been the recipe that we've used and that we've consistently rally around all of our investments. Put simply, CME Group is the world's largest and most diverse exchange. We have customers in over 150 plus countries around the world. Our offices are primarily centered in Chicago. We have offices all over the globe to support our growing customer list. Our markets trade 24/7, and we have a follow the sun model. What's really interesting about CME Group is that if you look at the notional value of the currency that flows through CME Group in a calendar year, it equates to $1 quadrillion. That's a 1 with 15 zeros. It's a very impressive number, and it really emphasizes the global impact that CME Group has on the world. Another thing you may not know about CME Group is that we are essentially a combination of, through acquisition, mergers, we have a lot of the storied exchanges kind of make up the CME Group brand, including that of the Chicago Board of Trade, the New York Mercantile Exchange, the COMEX Exchange, and then the classic CME Group Chicago Mercantile Exchange. All of these companies have been merged under the CME Group brand, leading to a world-class, diverse exchange. Some of our benchmark products that you can trade on CME Group include agricultural products like corn, wheat, soybeans, to energy products like crude oil or natural gas, as well as precious metals like gold and silver. And to some of our more innovative products like E-mini S&P futures or Eurodollar futures. Even recently, we launched a Bitcoin ETF as part of that. So we are constantly evolving, looking for new ways to innovate, to provide the best marketplace for our customers to manage their risk. Now, looking at who we are at CME Group, having been around for 100 plus years, we are not a born in the cloud organization. We have a lot of investments in our data centers and from a trading standpoint the game for us is really low latency and specialized networks, and that's the market that makes up our industry. However, like many organizations, we look to innovate constantly. And one of the ways that we've had success innovating recently has been leveraging the cloud, specifically AWS, where we can complement our business with leveraging what the cloud is best suited for, which is elastic compute, cost-effective storage, as well as access to managed services that make the operational burden a lot less and allows us to do more. In my team, the platform engineering team, we embrace this philosophy and look to find ways to innovate and automate wherever possible. As you can see, we deal with data. The data we deal with is very fast data, right? Around 2 billion messages a day we have stored and we process. Around 20 million contracts settle at CME Group every single day. Again, and we're leveraging the power of AWS to store this data and make it accessible to support other services like data science and data analytics. So with all that backdrop, I think now we can dive into the specifics around the presentation here today. As I mentioned earlier, we were faced with a problem where we had a growing list of companies and vendors and acquisitions showing up that required us to introduce integration with them to capture some of these data feeds for our business functions and other needs. At the time, we were building a lot of bespoke solutions, so one-off engineering efforts that were a little short-sighted or too tactical. So we really wanted to understand that. We also wanted to address the problem where it was taking with these custom bespoke solutions. We wanted to see if we could get the engineering effort down to hours rather than weeks, so that we could focus on other more strategic initiatives. Again, this growing demand for SaaS data provider feeds like Google Analytics and Salesforce is also taking CME by storm, as our business users really want to get that edge and kind of know the customer better. And the final problem we were keen to address was, how do we enable this for data science? How do we put it in the hands of the user so that it's usable out of the gates? Additionally, as an architect and core tenet of our platform engineering team, we wanted to make sure that this solution was something that we could manage and that we could operate. We are not a huge team, so for us, making things self-service, making things configuration-based are big drivers for us. Again, to get adoption and to make sure that the users can consume our services with little touch from us. We also wanted to make sure, like any cloud solution, we wanted to make sure that it was cost optimized, scalable, serverless if possible, so that we just plug it in and it just works. And then we knew we had a growing list of integrations to come, so we wanted to make sure that whatever solution we went was scalable and was easy just to add on more and more capabilities. So with that in mind, we created an architecture that we call the data ingestion architecture. We're going to walk through this data architecture and the various kind of dimensions of it. We break this down into 5 pillars, and this is how our talk will be broken down. First, we're going to talk about data collection and how we actually enable these third parties and SaaS providers to publish data to us. And then we're going to talk about the data routing solutions and how what do we do? How do we move the data around to where it needs to be? Then we're going to talk about our data transformation requirements, where we needed to actually, do a little ETL on the data to make it usable. And then we're going to wrap up with our data science-centric discussions around how do we catalog this data, and then how do we practice data science at CME Group. So with that, let's talk about data collection. Regarding data collection, as I mentioned, we were going down a path where we were actually engineering bespoke solutions with some frequency. A project would come up, they would need to get some data from a vendor, so we would end up building, a one-off type of problem or project, and we would be doing this kind of blindly with, too often. When a light bulb went off and we said, what if we did this a little differently? What if we were able to kind of build something more extensible, more scalable to address our growing needs in this space? We also wanted to make sure we reduce data exposure, right? So we are a regulated organization. So we need to make sure that our private buckets and our private data remain private, as to avoid being on the news, which is important to us. The other thing that is important to us is that we wanted, since we manage our kind of public cloud presence, we wanted to see if we could address the growing complexity of our S3 bucket policies and how we do event notifications on our buckets. So this is actually a feature recently launched at the time when we were kind of designing the solution, which was S3 access points, which posed a unique opportunity for us to evaluate. So we wanted to make sure that as part of this architecture that we gave the AWS S3 kind of services, including the access points, a real hard look to see if this is something we should invest in the future. With that, I'm going to hand this over to Kirti, who's going to talk about S3 access points more in detail.
S3 access point simplifies control for a shared bucket. Our customers today use S3 access point for various use cases like having decentralized team, data mesh architectures, cross-account data exchange, and many more. In case of CME, we needed a shared bucket so that we can get data from external parties as well as newly acquired companies as part of the integration. Also, we have a limit of 100 buckets, which is a soft limit per account, and then 1,000 bucket is the hard limit per account. So having an individual bucket for each of these parties didn't make sense, as it will be very easy to exhaust that limit pretty soon. Before access point, if a user have to access objects within the bucket, they can do so by using bucket host name. Now with access point, users can access objects using dedicated access point in addition to the bucket directly. Access point by default is regional and private. So this feature is very attractive to most of our customers. Moreover, customers can make sure that access point can be hit only when the traffic is coming from a specific VPC and the buckets are not accessible via internet. Now, if say CME was not using the access point, then each time a user or role needed access, then they would have to update the bucket policy to add that user. Again, as the number of user increases, then the bucket policy can get more and more complex and hard to maintain. Moreover, we have a limit of 20K on the bucket policy so that it cannot grow beyond that limit. By using the access point, CME was not only able to simplify their bucket policy, but they were also able to reduce the blast radius. Now here I'm going to share with you a simple bucket policy. So instead of having a one big bucket policy which gives access to all the users, we have a simple bucket policy which is delegating the access to the access point. And then we have a access point policy for finance user, which is giving get and put access to the finance user. And then similarly, we have a data science access point policy, which is giving access to all the objects with the tag of BI to a data science user. Now with this, I would like to hand it over to Rick so that he can discuss the architecture in more detail.
As Kirti mentioned, we landed on S3 access points as our solution for how we were going to connect our vendors, our AWS centric vendors, and these new companies, how we were going to connect with them to our account. Essentially, our solution for this data collection is really to create this centralized edge bucket. This is essentially a staging area, a landing zone that allows us to keep our private buckets private, but we enable these S3 access points to our to these AWS accounts. Again, the beauty of this S3, this staging, this kind of edge bucket staging zone is that we view this data as essentially temporary, kind of just strictly inbound data, right? And there's no long-lived storage there at all. This architecture allowed us to simplify our bucket policy so that we no longer have to add the composite IP addresses of all of our kind of edge customers. We can essentially delegate the access to for each producer to their own access point that's bound to their own VPC ID or public IP. Essentially, the bucket itself is never public or fully open to the world, which is very important to us. And as I mentioned, the additional policy that Kirti had showed is that we can apply to any access policy allows us to enforce additional IAM constraints, including things like which KMS key the producer is able to use, or as well as enforcing things like object ownership. So a very scalable and a very nice decoupled means for us to get that data in a very secure and operational way into our external bucket. So moving on, again, that portion of the solution was really focused on where we had a data provider that was native to AWS that was producing data. Now if you recall, the other part of our challenge was really how do we handle SaaS data providers, things like Salesforce, Google Analytics. We have a very healthy list of 20 plus data connections that our business wants us to capture and harness. So we needed to make sure that we were, we had a good solution for this as well. One of the things we have at CME, we do have commercial agreements with and commercial usage of tools like MuleSoft, which has that kind of inbuilt connectors and things of that sort. But we also wanted to make sure that this was cloud native and that we could respond to these data feeds without leveraging our data center environment and pulling data up. So for us, the opportunity was to evaluate this to Amazon AppFlow. After a rigorous security review with our architecture teams and development teams, we decided to go with AWS AppFlow. If you're not familiar with AWS AppFlow, it's effectively a managed service that allows you to connect data streams or data services like Google Analytics and Salesforce from AWS, and then be able to kind of pull the exports of your accounts to something like an S3 endpoint or Redshift cluster and whatnot. So this provides a very kind of easy integration that's essentially operationally, little effort to manage. It's simple, it's cost effective. Again, it was more efficient for us than setting up these captures in our data center using our commercial tooling. So we just plug it in, point it at the bucket, and then it just works. From a security standpoint, it addresses our needs around encryption. As you can have encrypted, communication to these data providers using, dedicated KMS keys. And then probably one of the best features of AppFlow for us is this ability to do scheduled and incremental flows. So our users, have the ability to define when do we capture the data. Is it hourly? Is it end of day? As well as, the fact that it supports incremental flows, which is, it will not, if we pulls hourly, it has some snapshotting and some, so that it will not kind of re-pull data, so it handles duplicates very, very well. So, and again, it also has support for kind of some modern data formats like Parquet as an object. So what we do is we had set up AppFlow with Google Analytics, Salesforce, and Pardot. And again, we enable this through our Edge bucket. So if we look at our entire data collection architecture together, this is what it looks like. So we're really happy at this point. We've gotten, we've gotten a very extensible or extendable architecture in place to get access to this data. All right, now it's all landing in our external bucket. Now let's talk a little bit about what do we do with it once it gets there. So we're going to talk about our data routing specific requirements. So regarding data routing, we had to think about how we wanted this to look and how we wanted this to behave. So it was crucial for us that this architecture was event-driven. We didn't want to have a lot of wait time because this bucket is a landing zone bucket and it is a temporary storage location. We wanted to make sure that that data that was flowing in was being acted on as soon as possible. Another key requirement for us here is that we wanted to make sure that our routing architecture supported multiple destinations based on our storage strategy for each feed. Because we have solutions where we have different storage strategies for our commercial data, where we have aftermarket data products, as well as our compliance requirements, archival data strategies, where we just look to kind of just lock and key the Glacier kind of raw data, as well as our business intelligence data lake buckets. So we wanted to make sure that any given provider could have that data feed could result in multiple destinations based on the needs. So that was important. Another key requirement for this routing solution was that it had to have been configuration based. We didn't want to introduce engineering efforts to add new rules and stuff like that. So it really was important that we're taking more of a kind of a config based mentality around this. With that, I'm going to hand it over to Kirti, and she's going to walk through some of the unique services, EventBridge, that we looked at, as well as step functions.
Amazon EventBridge is an event bus service that makes it easy to ingest and process events across AWS services and SaaS application. Many of you might be thinking, why did we choose Amazon EventBridge here and why not S3 Event Notification? Let me give you some points why we went that route. S3 Event Notification today permits generation of notification when certain events happen in your S3 bucket, but it does not support today regular expression matching and wildcards. Also, S3 Event Notification, it limits the number of targets. It right now supports SNS, SQS, and Lambda as its target, whereas Amazon EventBridge supports 15 plus AWS services as its targets, like Step Function, Kinesis Firehose, SNS, SQS, Lambda, and many more. Today, in case of CME, we are using EventBridge rule to trigger when the notifications are received, events are received, but it does give us the opportunity to expand it to other use cases. Say if tomorrow, if CME wants to run the EventBridge rule on a schedule, say if they want to process a stream of data files every 15 minutes or so, they will be able to expand it to that particular use case. As events are ingested into CME's external bucket, whether it is coming from one of the newly acquired companies, from vendors, or from SaaS applications, a manifest file is generated once ingestion is complete. The manifest file generation put event triggers the EventBridge rule, and on the successful match of the rule, it invokes the associated step function workflow. It all starts with an event source. Source can be any of 115 AWS services. In CME's case, it was S3 bucket. Event source can also include custom applications you write, or it can be SaaS applications. At core of EventBridge are the event buses. Once you have the event bus, you can associate rules with it. By writing the rules, you can route it to multiple targets. In our case, we are all our targets is a step function workflow, but you can have one rule which routes it to step function, another rule which routes it to SNS, another rule which is routing it to Kinesis Firehose, and so on. And all of these rules are processed in parallel. There is no particular order in which the rules are processed. Here I am showing you an example of event. The event, this particular event is based on a file coming into S3 from vendor XYZ. The bucket is external bucket, and the name and the prefix of the file is sample prefix. Let's say if we have a simple rule which is based on the file coming into S3 from vendor XYZ, then on the occurrence of this event, we will have a match and the event will be routed to its associated target. Now here we have a more detailed rule which is based on the prefix of the file. Now if the bucket is external bucket and the prefix of the file is sample prefix, and when this event occurs, there will be a successful match and the event will be routed to its associated target. In our case, the target is AWS Step Function. AWS Step Function is a serverless solution for orchestrating business workflows. The workflows you create, it helps you connect and coordinate AWS services using service tasks. For example, you can invoke a Lambda function, you can run a EMR step, you can get an existing item from DynamoDB table, or you can put a new item into DynamoDB table, or you can even submit a batch job and wait for it to complete. There can be many other workflows that you can create. Now I would like to hand it over to Rick so that he can discuss on the CME workflow.
Yes, as Kirti had mentioned, the use of these services came at the perfect time for us. As Kirti had mentioned, we are prior to this, we were using for bucket eventing. We were using the bucket notifications, and we were constantly running into challenges where multiple workloads were being tied to buckets, and this was interfering with our dependency management within our automation pipelines. So the ability to decouple the events from the buckets themselves was a really it saved us a lot of operational headaches, and we're happy to leverage EventBridge for that. So if you can see in this architecture, we are also, instead of leveraging kind of like one-off lambdas on this, we decided to kind of start to build the foundations of a really nice data routing workflow using step functions. So as objects flow into our buckets, we're initiating via EventBridge our step function kind of workflow, which effectively takes, as part of the event trigger, the first thing we do is we are fetching a configuration for that particular source prefix to see if there's any sort of routing rules defined for that. So for this, we chose to use Dynamo database. Dynamo is a really scalable key value pair serverless data storage solution that for us just made sense. It's really, we manage this entire architecture through Terraform, so just a very easy solution to deploy and implement. As every object flows in, we consult that Dynamo database and we look for the specific routing configuration, and from there we make decisions on where the objects need to go, right? And as I mentioned, it supports multiple destinations, so we can essentially target the buckets where these are required for. Again, one of the nice things about this is that this, as I mentioned, this keeps our private buckets private. We're not overexposing those our kind of crown jewel buckets, and we also were able to kind of add some basic capabilities around file prefix renaming in order to make it more consistent with our taxonomies within our existing buckets. So if we look at the layered architecture, we have the data collection bits on the left, and and how data is flowing in, and then we moved more toward the right, which is actually how we get the data in the buckets from a routing standpoint. So, and now we have our data in our private buckets. So this is very good. We're very happy with that. And then a new requirement revealed itself. One of these data providers that we onboarded had a requirement for us to have a kind of near real-time, very time-sensitive response from within our data center. The other part of that challenge was that our data center teams were not well versed into the cloud, so providing them a cloud native interface was out of the question, as that the project timelines were rather intense. So we had to think of a way for how to give this data, make it available for kind of a time-sensitive requirement that required time-sensitive delivery on our kind of core market data real-time channels. So after thought and looking at this architecture, it became evident that this was very easy to do within our current architecture. Because step functions is decoupled from the rest of the bucket, for us to add another configuration that takes a Kafka topic and because we have networking enabled and we can tie our Lambdas to our VPCs, we were able to kind of reach our Kafka infrastructure, by simply adding another step in our Dynamo configuration that supports a new destination of Kafka. Now we have Kafka at CME. We're very mature within Kafka as a primary kind of messaging protocol and transport for a lot of our data sets. So we have Kafka in our AWS that we depend on, as well as in our data center. So what this was able to do is provide a fan-out architecture for data streams that are coming from AWS, so that we can have multiple consumers within the data center, and they don't have to be bothered with learning a new technology or a new cloud-centric integration. This was a very nice success and an example of how extensible this architecture became. Now, at this point of our journey, we've got a good handle on our data providers and an automated way through our Terraform modules to add new users and new data producers at will. We had some challenges around the data consumption, and we're going to talk a little bit about what those challenges were in the data transformation portion. So as users were getting their hands on that raw Google Analytics, Salesforce data, we became aware of the complexity of that data. If you're not familiar with those data sets or other data sets that come from these SaaS providers, they're very proprietary. They're not optimized for query. Some of them are incredibly nested. So they're not specifically usable out of the gates for our users. So we knew, because our focus is driving adoption and getting toward that business intelligence, data insights, that we needed to do something better here. Additionally, in the back of our mind, we knew that to get adoption around our data lake architecture, we needed to make sure that we have consistency for how data lands into the data lake. We should not have, we have a kind of decentralized data lake where data providers are responsible for making sure that data is landing in the data lake as well as it's optimized for usage. So what that creates is a challenge around, how proficient should these data producers be in designing and architecting data for, analytics and reading. So that was a bottleneck that introduced high learning curves for these particular users, which we wanted to see if we could take that burden off them and have the producers just focus on producing high quality data. Another challenge that we had is that a lot of our data producers, right? We use streaming formats like Avro or other for our kind of real-time data sets, and most times they're optimized for write, since we don't want to lose messages and we want to make sure that our kind of like real-time pipelines are optimized. But at the end of the day, we do the kind of columnar format conversions, really to make sure that we're compacting and making sure that our the column organization of the data sets are optimized for our queries. This results in like delayed data access. If a user wants to get access to something that's happening midday or top day, they effectively have to wait till the end of the close of our markets for them to get actually access to the optimized query. So that was always in our back of our mind and what we could do. We were able to address that, and the data ingestion service was born out of it. So if you're not familiar, we were able to kind of put our heads together and figure out what is a way we can have like ingestion or like a transformation as a service. So how can we do that? And then what was really interesting for us was the Apache Hudi project, which was open sourced by Uber. And essentially this is it's it allows us to address a lot of those initial concerns. By us introducing a very lightweight ETL transformation service that's, guess what, configuration-based in our Dynamo tables, we're able to provide our users with a means to provide a schema conversion template and then be able to kind of transform those into an optimized query set. Apache Hudi does a lot of awesome things that makes our data accessible almost immediately, so no more end-of-day batch conversion. It does a lot of optimizations in the background. You know, it's ACID compliant, and it does like a lot of repartitioning behind the scenes and compaction, which make it very, very powerful and cost-effective as well. And ultimately, just runs as a Spark application on our existing infrastructure. So we don't have to. The users really are focused more on schema conversion and some partitioning, definitions, and then we take care of the rest, which has been really powerful. And a really nice added bonus of this is that, again, we were approaching this really from that SaaS data provider those data sets. But we saw a larger opportunity that we could, with what EventBridge can do, how it can target even multiple buckets. But we were able to leverage this data transformation service around our internal data sets. So we have a lot of data that's coming from our data center that's Kafka-based or it's storage gateway-based, file-based. Now we can leverage this data ingestion service, Hudi-based process, for those data sets as well, leading even more to consistent data lake formats. So if we look at the architecture now, you'll see we have we've extended the configuration to support the Hudi transformation, the data ingestion service. So if there is a data ingestion configuration, we effectively we kick off that process. We look up an EMR cluster that my team manages platform, and we essentially run this through a transformation process through an EMR cluster. This is the only infrastructure, the physical infrastructure, I should say, the only infrastructure that we manage in this entire architecture, which is pretty awesome. Even in light of that infrastructure being managed, we are obsessed with kind of cost optimization. So we do have, a couple things worthy of note is that we are kind of managing that Hadoop or EMR cluster around kind of auto scaling groups. So we scale down to the workloads that are there and scale up when needed, so that we can kind of make sure that this is optimized for cost, since we don't really want to have a long, idle footprint of that cluster. Another, awesome, capability here is that Step Functions natively supports EMR steps. So it makes it very easy for us to invoke, cluster jobs. And then I think another really, something that worked really well for us was that as of, earlier this year, Amazon Athena, which is the managed kind of Presto query service that Amazon provides, announced support for Hudi formats and stuff like that. So this really worked well into our kind of longer kind of data lake architecture solutions. So now that we have good quality data that's accessible or that's queryable by our users, we're going to talk a little bit about how do we catalog this data and make it accessible. Again, around our data access and data catalog requirements, we needed to make sure, yet again, that this is a self-service for our users. That if users want to register new tables or data sets, that it's something that they can do on their own with limited involvement from us, from the platform engineering team and architecture teams. We wanted to make sure that our catalog had consistency, that we had defined some specific naming conventions for how columns get named. How do we mandatory tagging, that and the things of that sort. So we wanted to enforce that while making it self-service. And we also wanted to provide a solution for how partition management happens on these data sets. In the past, when we managed our environment, it was kind of incumbent on the data providers to actually register each partition on top of every batch job. that was a little time consuming for them, and it didn't fit all of our existing use cases where data is coming. So with that, we made a migration from our managed kind of Hive Metastore and environment to AWS Glue. AWS Glue is Amazon's kind of data catalog service, which is Hive compatible. And our solution here really involves leveraging Glue as a data catalog. We provide Terraform modules for users to request and add new tables, change tagging. Everything's managed through a pull request. So the data producer provides a pull request to our kind of repos, and then the way we can enforce consistency is that on the pull request, we added a workflow that runs our kind of open policy agent policies. If you're not familiar with OPA, Open Policy Agent, it's a Netflix open source project that is a kind of an all-purpose policy framework that's written in Rego, or that uses Rego. So we were able to leverage OPA to enforce a lot of those requirements around naming conventions, mandatory tags, database names, and things of that sort, so that we can kind of, and then this part of the process will provide feedback to the user in their pull request through a comment on their pull request. So again, we have a pretty rich backlog of policies that we're looking to add, but this has become a really nice part of our solution to make sure that we're, from a security and compliance standpoint, that our pipelines and our catalog is protected. Additionally, as part of our self-service, we give the users the ability to define their own glue crawlers. So they can do partition management, and they can decide when the crawlers run, and then as well as, but for us, this is not for table discovery. This is strictly for partition management. And then to round out the data access architecture, we have Lake Formation as our entitlement solution. We used to run with Apache Ranger. Lake Formation provided a lot of capabilities for us that we just couldn't pass up. Specifically, the most important thing for Lake Formation for us was that it allows us to do cross-account sharing. We don't have to move data around to make it accessible. The data never leaves the environment that it was created. So our production buckets, we are able to share those via Lake Formation down to our child data science accounts and delegate them out. And then from an access standpoint, we use a lot of role-based access, with our kind of SAML federated roles, so that works for us. And then finally, Lake Formation provides the ability for us to kind of, through the RAM sharing, it allows us to put an alias around where they came from. So our users don't get confused and look at a particular table from data science. They'll know that this is from our dev account, because when you deploy tables in like a CD fashion, you need that delineation to know which data set's what. So if we look at the architecture, now what we've added is the data lake components. So now we have, all the data collection happening, the routing, the transformations, and now we've added this beautiful data lake components. And again, I failed to mention that when you have Glue and Lake Formation, another incredible benefit is the ability that Athena just plugs in out of the box. So now we're going to talk about our data science portions of the solution. Now that we have data accessible and it's available for users, let's talk a little bit about what are the challenges we wanted to address as part of data science. From our data science project, we really wanted to make sure that we gave our users flexibility in software choice and compute. We didn't want them to be constrained on either of those, because the art of data science is very fluid. We wanted to make sure that our data science environment was isolated, locked down, and that we had very little exposure to the internet. We wanted to make sure that our production data sets were servable through our data science account. And we wanted to make sure that our users could collaborate within their own departments. So for us, our data science community is broken down into kind of departments. So we wanted to make sure that they could share insights within those departments. A little note on what data science means at CME Group. So I thought I'd hit a little bit of the specifics around what are the types of things we're doing in our data science communities. So obviously in what's featured in this deck is really around how we can leverage the data streams and the SaaS data providers to provide, to find more customers, identify our customers early on, and things like that. So generating sales leads is a pretty big one at the moment. Additionally, there's a lot of interesting things happening around market events, whether it's something like Brexit or an upcoming election. We can actually get the pulse of the world and around looking at different sectors and asset classes to see how they're behaving. If gold is trading higher, there's that typically can be, our economists, our chief economists will look at that and identify that there's a fear of inflation changing. So you can essentially get the pulse of the global economy through how our markets are trading around these events. Additionally, there's always, like many organizations, you use data science to find bad actors and fraudulent, use of your environment, So that's always a focus, as well as just optimizing our pricing engines and looking for market volatility. Our data science architecture that works for us looks like this. We are, in a nutshell, we have a cloud native AWS, a cloud native environment. This is a single AWS account that has a single private VPC with no internet gateway. We supply membership, or membership to this is all based on a departmental membership. So every given department, like marketing or market regulation, there's an Active Directory group where users request access to. Once access is granted to these kind of AWS, federated roles, this gives the users the access to an S3 bucket that's departmentally, kind of isolated with its own KMS key. The users then have the access to a variety of compute services, and for that we're leveraging Service Catalog. AWS Service Catalog provides kind of a self-service way for these departmental users to be able to request various compute resources. And for us, our compute products include, the users can create like departmental EMR clusters, SageMaker notebook instances, or even just a simple EC2 instance that may be a GPU instance or not. Now, once the users secure this infrastructure, the question is like, well, how do they get access to it to actually configure it and run things on it? For that, we're using another AWS service called AWS AppStreams, and this provides a virtual desktop that users can log into privately through Amazon networking, again, without creating any sort of unnecessary ingress point. It privately launches for that department, that instance, and since it is bound to that departmental security group, it can only access the infrastructure that's for that department, and from there they can do other things within that instance. We also provide access to whatever software that the user may need, including their own private stash repos through the magic of Private Link in our data center connectivity. Finally, a couple other points is our users we also provide them a storage gateway that's SMB Windows mounted to their laptops, where they can add and kind of pull data out of their departmental buckets, so they can collaborate as well as do analysis on data that's local to their machines. And I guess the final point I would mention is that the entire data lake architecture, the lake formation, and those data sets are accessible through lake formation sharing, which makes it really, really easy to use with Athena workgroups that are departmentally based out of the gates. Now, in light of all that, I wanted to highlight a couple of the most powerful kind of use cases that came out of this entire initiative. With the use of the app flow, step functions, and everything we've talked about thus far, our users were able to connect the dots and be able to create this client journey dashboard, which essentially recreates the users through looking at all of the digital assets that we have access to, from our kind of external websites to some of our marketing campaigns to actually our transactional systems. We were able to connect. Our business users had a really innovative idea to connect all of these interactions even before the user created a user ID. They're able to kind of correlate all this information and create a nice kind of a lineage of how the customer, came to be, and what he was looking, what the prospective customer was looking at prior to stepping up. So this created a really incredible model and got a lot of excitement around our marketing departments. To add to that, the users were able to also to create kind of an alert-based model that allows our users to track prospective clients and firms from joining CME or looking at other products, finding cross-sell opportunities, based on their web activity, or how they interact with our external CME Group website or whatnot. So these are really powerful, and these are only the tip of the iceberg for us around this front. We're only looking to capture more data and things of that sort. Now, I would also like to maybe highlight a few of these. What did we learn from this entire experience? From this architecture, and what worked and what didn't. Obviously, the most important item was really starting small and then layering in these other architecture pieces. But really, having a big picture in mind. We have a pretty healthy pipeline of things we want to do in this architecture, but it was important for us to kind of deliver something that met the minimum need, and then we could evolve and get a feedback. Operational visibility is also something that we kind of strive for here, to make sure that the solutions that we come up with here, that they just work, and that doesn't require a lot of operational burden on our side. Again, self-service is key. It's important to have really good documentation, katas, things of that sort, to make sure that it is usable and that it's understandable, so that you don't have to do a lot of hand-holding in terms of like rubber. That's the only way you'll get adoption, and that's something that we've learned that lesson in the past. So it's just really important to make that a core tenet of how products are delivered. The last point is not so glamorous. We present in the picture. For us, it works. It does what we need. But there are incompatibility issues with some of these services that we're using. So, like I said, for us, it's not. I mean, in the aggregate, this works. But I would stress on the point that in the way AWS delivers their products, there's always a way to get into the feedback loop around these particular products, and it's always important to work with your account teams, like we work with Kirti very closely around enhancements, features, things aren't working exactly like we want to, or what's coming next with AppFlow. So they respond to that feedback if you reach out and ask those questions. So that's always been something that we kind of we stress on, is just making your voice heard, and you'll be surprised what comes. Yeah, next steps for us, we're planning to add some inline file scanning around this architecture, so that it's just part of the step function. We want to add Salesforce as a destination for AppFlow. So instead of just S3 or Kafka, we're likely to add some additional kind of more specialized, AppFlow supports Salesforce as a destination. We plan to front the entire solution with SFTP using Amazon Transfer families for the non-AWS native data producers to round out that solution, as well as a couple other things. I hope today that that everyone got a good understanding of kind of how we were able to kind of have success and leverage the power of the cloud to meet and kind of serve your business data intelligence teams. I hope that we were able to inspire users to leverage these services, as well as realize that this is a very possible and a straightforward thing for a team to create. We look forward to talking more, and thank you very much for your time today.